Figure 6.63 is a cam layout. It is in inches, and we're staying with the 2 decimal places. So this will be just a standard strategy. We'll probably end up with the front profile. Would be helpful if it was centered. We're not really given a coordinate system or a location, 0, location for our starting point. 0.56 by half an inch. Well, don't kind of see some of the hidden lines, but we're not told if that goes to a drill point. Since the thickness and the depth, kind of hard to tell. We'd want some more information on that if we're pulling mass properties, and this is a question on the examples CSWA or the CSWA. So we're going to do a new. Grabbed one more part inch. Going to generate the front plane, and we'll go with a line. Come back over. I'm going to go ahead with the full width. We'll put the angles on as a separate piece of geometry. Bring off the tangent arc. So that continuous arc, again, I pull the line off. I go back to the start point. I pull away, and that switches me to arc. And I will, if I continued, I would be back into the line command. So 1.5 inches on the height. 3.19, 3 3/16 on the width, 2 inches on the arc. Alright, and one of the other things to note I'll mention again is I want you to get into that sense of pace and speed, because that's one of the most common issues with the CSW and the CSWP is running out of time. So I'm not holding back as much as maybe I should, but the expectation is that you're going to kind of get a sense of how fast you should be going to complete out that test. Alright, so we have a limit dimension 0.62 to 0.63. Maximum material condition will be 0.62. And those are set up to be in line. And our width was the 0.62 plus 0.62, which would be 1.24. So let's do that math. 0.62 plus 0.62. The problem is the stack up of our geometry is probably going to really be at 1.25. So I'm guessing, I'm making assumptions, but the rounding down, we're just going to have to see where those numbers fall out. Very well could be 1.24, but that's going to be the problems with our 2 decimal places. So I would expect on the exams you would have the 3 decimal place numbers, and if that's the case, if we were given 2 decimal places, I'm going to have to stick to it. I don't have the luxury of that rounding error. Alright, so easy enough to change. We're going to extrude this out. I included the hole as a nested, and one of the things I haven't been using is the shaded contours. This will kind of give you a sense of one closed region. If this does not go to that lighter gray, then that means there's an opening somewhere, and you are probably going to get a thin feature. The inside circle has a slightly darker gray, which shows that it's nested, and that's kind of helpful to start. I want to go mid-plane then, once I create my boss extrude, and the width is 2.24. Alright, so then the steps, could sketch from the top or the bottom, and because this is symmetrical, then go ahead and tie these two together. So just a center line right down through the middle of the part at the midpoints, or at the origin in this case on the left. We have a step and a step. If I select right to left, then we can mirror entities, and we're ready to start putting dimensions on. So 1.62. And if you can't tell, it does kind of drive me crazy that we're not going out to those proper fractional dimensions. The let's see, the 0.81 goes to centering, and then the depth, that was our first 0.62, and then the full depth, we have a 1.19, and an overall of 2.12. Alright, so that gives me my geometry, the 2.12 to the end, 1.62, the 0.81 centers it, the 1.19. Trying to think where, if that would, if that picks up the center, if it's just an assumption because that one's centered. Okay. Well, the 0.53 on the side, if I add that as make this dimension driven, if I add that as a driven dimension, we're close, but because again of the rounding errors and the selections that we've made, may or may not be ideal. So on the other hand, if I made this 1.1875, that 2.5 thousandths difference being added to the side, no, that would bring it up to only up to like 0.5275, so not quite there. There's a little bit of stack up going on, and that's the kind of thing you don't want to do on the test, is start obsessing about a number. So we're close enough, we're working in, and if I put that back to 2 decimal places, chances are it's going to be fine. So through all, set our depth. On the front side, we'll go in and generate our angle. I can leave this probably as an open profile. We have 30 degrees and 30 degrees. So pick the top edge. Whenever I'm doing those open profiles, I do want to make sure that it is a continuous profile, that if I'm setting my pencil down on the piece of paper, it doesn't lift until I get to the end of the profile. So 30, and what do we have? 0.75, so 0.62 back from the edge, and then that one goes defined, so I can select the 2 endpoints, and those will be vertical. That looks pretty good. We'll go into the features, Extrude Cut, make sure that my arrow, okay, so the arrow for the side to cut is pointing down. If I reverse that, then all of this goes away. We just want to take the 2 angles off, and then this is going to be a through all, and then it defaults to through all both. Okay, so that's my front, and then we'll go to the top, and these were 45. Since that edge is now driving the 0.62, I'll just pick that up as a coincident. And we're going to be symmetrical, so if I select the midpoint, go into the control on the edge, set those to midpoint, then we can set our angle of 45 degrees. Okay, also an open profile, so features, Extrude Cut, through all. My direction is on the wrong side, so we need to flip the side to cut or double click on the arrow. So if I double click, highlight in orange, double click, that's going to give me the flip on the side to cut. Alright, so decision time, if this is a drill or a flat bottom, we don't really know because the interior geometry is not really shown. My assumption is that it would be a drill point, and I like the hole wizard better, so we're going to select the face, press the S key, go into the hole wizard, and we have the depth, and this was 9/16 or 0.56. Make sure we're in inches. Let's go ahead and set it to fractional. and we'll come down to 9/16. And if you're not familiar with the decimal, show decimal values, and then when you do the pull down, they'll be available. It's not an up to next, it's a blind in condition. Again, 2020 added the to shoulder. By default, previous versions were at the shoulder. We can also go to tip. The depth is generally to the shoulder, but if I knew a distance and I wanted to not break through that near side wall, then I could set the tip. Alright, so we're on center. That's going to be the origin vertical to the point, and then the depth point or the height was 0.75. And since that was 1.5, it makes sense that it's centered. 7. And then the main difference, if we go to wireframe or to hidden lines, and go to the display style if you haven't added those icons yet. Hidden lines visible, we're going to see that drill point. If this is mass, then I want to see that on the drawing. If this is just flat bottom, I can draw the circle, extrude it out 1/2 inch, and know that it's flat bottom. But from the manufacturing process, I probably do want to include that that drilled. Our material is cold rolled steel, so we'll edit the material, and we're going to AISI 1020 apply, and with the finish all over, we have the geometry. So another quick look, make sure I didn't miss anything, and we go ahead and save. And this was 6.3 and is our cam.